Hi, and welcome to 5.2 Special Cases of Linear Equations. These have come up a couple of times. We're going to talk about them specifically with horizontal lines and vertical lines. We're going to start talking about horizontal lines. You could imagine any horizontal line you like. I'm going to put one. Oh, that didn't work. For some reason, it just doesn't like my ruler tool all the time. But I can imagine one right there. It was supposed to be a horizontal line at 1, 2, 3, at 4. So horizontal line. We talked in 5.1 about slope-intercept form. Y is equal to mx plus b. And I think this is a great spot to start to talk about horizontal lines and vertical lines. Notice how we have a y-intercept here of 1, 2, 3, 4. So my b is going to be 4. And the slope on a horizontal line, notice how I don't have any rise or run. So when I talk about slope is equal to rise over run, it doesn't matter how far left or right I go because 0 over any number is going to be equal to 0. So now I know that my slope is going to be 0 and my y-intercept is 4. And from a graph, I got those from a graph and I can plug those back into my equation just like we did last chapter. Y is equal to 0x plus 4. 0 times x, as we know, is just going to be 0, which we don't need to write. So I get y is equal to 4. So this is my equation of that horizontal line at y is equal to 4. Notice how, if I look at that, it doesn't matter what value of x I look, absolutely anywhere, it does not matter, off to the right or off to the left, y is always going to be equal to 4. And that can be the same case of any, and I'll get my ruler tool out again, of any horizontal line. It doesn't matter where I put it. There we go. This one looks like it's about at 1, 2, 3, 4, 5, 6, 7.5. It doesn't matter where I go. The equation for this line, it doesn't matter what the x value is, y will always be 7.5. Let's see if I can actually write that in there, 7.5. And this one, y will always be 4. So let's look at vertical lines. If I look at a vertical line, and let's see if my computer will cooperate when I get out my line tool, and I draw a vertical line, vertical up and down, horizontal left and right. For some reason, it really doesn't want to draw it on the grid lines. But we're going to pretend that this one goes through the 1, 2, 3, 4, 6. We're going to pretend it goes right through 6 so we get a nice number. So if we look up here, it didn't matter what x was, y was always a number. For a vertical line, it doesn't matter what y is. It could be anything. It doesn't really matter. These are going to keep going off. It doesn't matter where we look. X is always going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So for our vertical lines, x will always be the same number, -6 in this case. And again, it doesn't matter where I draw that line. I can draw it anywhere I want. Let's do another one. It's not going to do it for me. Let's try a second time. Doesn't matter where I draw. This one looks like a nice 0.5. We're going to pretend that's a little bit more vertical than it is. This is a 1, 2, 3, 4.5. So this one will be x is equal to 4.5. This one, x is equal to -6. And those are the equations of the line. Notice how for vertical lines it doesn't quite work in slope-intercept form. Or I guess you could conceive that it is in standard form from last chapter, but we kind of break with forms a little bit for vertical and horizontal lines. That's really the only way to write a vertical line, and there really is only one way to write a horizontal line. And that's kind of what they look like. So let's look at a couple of examples. Write the equation of a line passing through the following points in slope-intercept form. This one has nothing to do with horizontal and vertical lines, but there's a few questions like this from the homework in 5.2, so we're going to do an example. So this is another one of those questions where we're going to ask, what can we do? we're given 2 points, and we know, we've done it a couple of times already, with 2 points we can find the slope of a line. So we can use m slope is equal to y2 minus y1 divided by x2 minus x1 to find our slope. No, it doesn't matter which is which. We can decide that this is point 2 and this is point 1 just for fun. I'm going to switch it around from what I normally do, because it doesn't matter. So my slope, this is going to be my y2, 2 minus negative 4 divided by my x2, which is 5 minus 1. Don't forget about that double negative. My slope is going to be, I think, a 6 over 4. Again, every single time we write a slope, we want to make sure it's in lowest terms. This one can, in fact, be reduced. I can divide top and bottom by 2. End up with that slope is 3/2. Okay, so I've got a slope, and we want it in slope-intercept form. So when I look at this, I end up with a y is equal to 3/2 x plus b. So I'm a little bit stuck looking for this b value. I could probably graph it if I wanted, but that's not really the point of this. To graph it, this one's supposed to be done algebraically. So what I can do is I can choose one of my points. It doesn't matter which, and I'll probably actually go through and do both. I'm going to arbitrarily choose this point because we have an x value and a y value here, and it should be on this line, which means if we substitute it in, my y value is negative 4. Wow, actually, let's just take this and move it up a little bit so I have some more space. My y value is negative 4 is equal to 3/2. My x value is 1 plus b. And notice now how I have an algebraic expression with one unknown. We should be able to solve it. First thing we should do, just about every single time we're doing algebra, is we would like to simplify. 3/2 times 1 is just 3/2. So I get a negative 4 is equal to 3/2 plus b. And what I need to do now to get b all by itself is subtract 3/2. I know some people are not the biggest fan of fractions, but there you have it. Negative 4 minus 3/2. And let's just do fraction work for funsies. Negative 4 minus 3/2. I'm going to have to turn this into a fraction, the 4 into a fraction, and then I'm going to have to find a common denominator, which is going to be 2. It means I'm going to have to multiply top and bottom by 2. B is equal to negative 8 over 2 minus 3 over 2, and b is equal to negative 8 minus 3, I think is 11 over 2, and I end up with y is equal to negative, or not a negative, y is equal to 3/2 x minus 11 over 2. Let's pretend we chose the other point if we wanted to. So I'm going to choose the 5 and 2. And I'm going to do the same thing. I'm going to substitute my x and y values in. My y value is 2, and that is equal to 3/2. My x value is 5 plus b. One unknown, we can solve this. I'm going to simplify. It's not a 1 this time. It's a 5. 5 over 1 times 3/2 is going to be a 15 over 2 plus b. I'm going to subtract 15 over 2 for both sides. Minus 15 over 2. Cancels on my right-hand side. I am left with b is equal to 2 minus 15 over 2. I'm going to turn this into a fraction. We have to make it a like denominator. I'll multiply top and bottom by 2. And b is equal to 4/2 minus 15/2. 4 is a positive, 15 is a negative. I end up with b is equal to negative 11 over 2. And again, I end up with y is equal to 3/2 x minus 11 over 2. Both of those points are on that line, which means both of those points should solve that equation. Let's look at B. I'm going to go back to a bit more neutral blue here. B, we are trying to find the equation of a line passing through the following points in slope-intercept form. We have a 5, 5, and a negative 3, 5. Notice how our y value for both of these are the same. So if I was to draw a very fast sketch, 1, 2, 3, 1, 2, 3, 4, 5, I would have a point here, 1, 2, 3, 4, 5, and a point here. You should be able to see that this is a horizontal line. There's no other way for this to be. If we remember from the previous page, for a horizontal line, it does not matter what our x value is, y is always going to be equal to 5. And I'm done skis. So if they're not the same, if it's not a horizontal or vertical line, you are in a bit more of a longer process. But if you can identify that it's a horizontal or a vertical line, we could jump straight to the x or the y is equal to something. Thank you for watching, and I just wanted to remind you guys a couple of keys for success. Number one, you got to do the practice questions. If the things I'm saying make sense, that's phenomenal, but you still have to practice and make some mistakes on your own. And that goes along with number two. If you get stuck, ask me questions, get in touch, write me an email, make an appointment, or leave a comment on the YouTube video. And step number three to success is look after yourself. Eat good food, get some exercise every day, and socialize as much as you can right now. I hope you guys are all doing well, and I will talk to you soon.